Welcome my dear students. Today we will learn the basic fundamentals of the Python. So in this session we will learn the few very basic concepts about the language Python. So the very first slides of the Python. So in this slide the first point is that Python is an interpreted high level general purpose programming language. From this particular line there is three concepts can be drawn. First of all, the Python is an interpreted language, means the language translator we are using is interpreter in the Python language. So the interpreter translates the program one by one and then execute it. High level language means the language which supports all other programming concepts, and the general purpose programming language means you can use the Python whatever you want to program. The Python language is created by Guido van Rossum and it is released in February 1991. The next point is that it is a case sensitive language. So the meaning of case sensitive language is that in this programming language the capital A and the small a having two different meanings. If we are writing any thing like small a and capital A, then these are two different things in Python language. Case sensitive means, for example, that you have created a password in a Gmail in a small letter, and if you are entering in the capital letter, it is shown the password is wrong. So the password is case sensitive in any type of application that what you are using. So when you are studying the Python or when you are programming any code in the Python, then you should have take care about the case sensitivity. Means when you are typing anything in the capital, in the whole program it will become capital, and if you are typing anything in the small, then it will small. The next point says that the Python is based on or influenced with two programming languages. The first is ABC or the basic language, and the second is the modular 3 language. So if you are asked from where the Python language is derived, you can say that the Python language is derived from the two languages, that is ABC and the modular. So from this particular slide the 2 marks has been drawn. For example, you can ask about the case sensitivity of the Python language, and the second, the creator of the Python language. Now moving forward, the next topic we have is a computational thinking. So before starting with the programming language, one should develop the computational thinking, that how you can solve a problem or how you can take a problem in the way that a computer can solve it. Means there are many ways in which a program can be solved. All the ways need to be understood, and the computational thinking refers to a collective thought process involved in formulating problems and solutions so that they are represented in a form that can be effectively carried out by a computer. Means when you have any problem and you have to create the solution for that particular problem, first of all you should know that how a problem can be solved or in which way you can solve the problem. Means the problem can be solved by breaking up, the problem can be solved by finding any particular pattern in the previous solutions, by comparing this problem with other problems, or how you can solve a problem. So when any particular question is given to you all, then what you will do, you will first find the way, the method through which you can solve it. So the computational thinking is created with these 4 different principles, that is decomposition, abstractions, pattern recognition and algorithm design. So these are the 4 key principles of the computational thinking, or you can say these are the 4 parts of the computational thinking through which a problem can be solved. Now the first principle that I am going to discuss, that is decomposition. So simply decomposition means to break down a complex problem into the manageable problems. Means if you have a problem to solve, so you can break a problem into small problems that can be managed easily and separately. First of all, solve the subset of the problems individually and then attach in order to solve a big problem. So with the help of decomposition, it is easy to solve a bigger or the complex problem in computer science. So simply in our daily life we can see, if for example if we are given to write a project or write a thesis, then we can simply break the thesis into the part. First of all, we will write the introduction, then acknowledgement, making the index, just go for the evidences or for the details of the project, and then find out the related pictures, and at the last we are writing the conclusion, and in the last we are writing the bibliography page. So what is these parts? These parts is a decomposition of the problem, that what we have to write, that is the project. You can take another example. To divide a syllabus, what is the syllabus? That what we are going throughout the year. So divide the syllabus into various small chapters is again decomposition of a complex problem into the simple problems. So simply you can divide our daily life problems into the smaller sub problems that can be easily management. In the similar way, if you are given a problem in order to create a code to solve the problem, so first of all we have to think that how can we break the problem. First, break the problem into the individual units, and after breaking the problem in the individual units, try to solve it individually, and when you will solve it, just again merge it in order to find the solution for the complex problem. Now moving to the next topic, that is pattern recognition. So for example, when we are solving one problem, then second, then third, then fourth, we are trying to find a pattern, and when we are able to recognize the pattern, then it is easier to solve the problem. As we are seeing any web series, there is a serial killer. So when there are simple pattern is finding in the killing process, so it is easy to recognize that this is a type of serial killer. So in the simple way, when we are observing or looking for the similarities or the patterns among and within small decomposed problems, so the identified patterns help solve more complex problem more efficiently. So the pattern recognition helps in order to find the similarities. So moving to the next topic, that is abstraction. So abstraction is the most complicated stage. For example, there is a many other aspects of the abstraction of any particular problem, but we have to find only the solution for which we are looking for. I can explain the abstraction in such a way. Suppose you all have a fan in your home, the fan regulator. We all know that we have to turn the fan to the number position, and the speed of the fan can be controlled by turning the regulator. But what will happen inside the circuit, we don't know. But when the electrician will come, he will know all the detail about the inner work. So what will happen when we are working on any particular thing, the abstractions means only that part of the information will be given to the user that are usable for the user, not the extra material about the particular thing. For now, taking one more example. For example, that you are telling about the mammals. We all have an idea about the mammals, reptile and other things. When we are teaching these mammals and reptile in the junior classes, we are telling only common structure. But there are many other specifications, other details about the species, but there is no need to tell those species to the students, because this is out of the course of those children. So what we are doing, we are giving only such details that are required by the students or that is specified in the syllabus. As the classes will increase, more specification is required. So what we are doing, we are trying to give the more specification to the students as per their requirement. So the abstraction is the only thing that what you can understand. A simple sentence, बस तुम इतना जान लो, इसके आगे तुम्हारे काम का नहीं है. So with the help of this simple sentence, you can easily understand the abstraction. Now moving forward, the next is generalization. So when we have many other specific problems and we are breaking it into the sub problems, then what we are doing to find a common pattern or the common thing. For example, if we have solved any problem earlier and we are trying to solve a problem today, and then there is a click that we have already solved the similar problems, and what we will do, we are copying the some part of the code from there and paste it, and the rest of the code we will be writing here. So when we have so many problems to solve it out, then what we are doing, we are trying to find something similar between the problems. So by finding out the similarities between the problem, it is very simple, or it can be easy way to solve the problems or to create the general solutions. Okay, so this is called the generalization. Or when we are talking about the definition of the generalization, we can say that the generalization refers to identified common or shared characteristics between two domains or problems, such that models or solution of one could be adopted or applied to the others. Okay, now moving to the next, that is algorithm designing. This is the very important part of the programming. When the algorithm is designed, you have to just translate the steps of the algorithm in any programming language. So algorithm is a part wherever you are developing the step by step solution for any given problem. For example, if you are asked to prepare a tea and you are asked to write an algorithm for preparing a tea, then the algorithm will be first take a pan, then pour some water and milk, add some sugar, add some tea leaf, then make it boil, and after boiling take out in the cup. So this is a step of making a tea. So algorithm is a problem solving technique in which you are writing the solution of the problem in steps. The steps are interrelated with each other, and the sequence is also interrelated. So you can say an algorithm is a sequence of steps that solve a problem by working on some input data and producing a desired outcome. Algorithm design involves creation and execution both. So the computational thinking is based, or you can say these four principles are the pillars of the computational thinking. So before starting to create a program, before starting to solve a program, you need to think that how can you break a complex problem into the simple problems, then how can you recognize a same pattern among the problems, and what the general thing that you can find among the problems, and finally you have to write the stepwise solution of the problem, and this is called the algorithm. So this is all about computational thinking. Now we will discuss where we can use the Python language. So we can use the Python language while we are developing the GUI applications, means the graphical user interface applications, website and web applications. When you will study further the Python, you will see there are frameworks available, just like the complete structure is available on the internet or in the libraries, and you will have to just make the required changes that what you need in your personal website. So As I told you earlier that Python is a high level programming language and it allows us to focus on the core functionality of the application. Means with the help of Python language you can program all the applications that are the basic, and all type of programming you can able to do with the help of the Python language. So every language has some features, some plus points, some negative points. So now starting with the plus points. So the very first I am discussing the simple feature of the Python. The Python is a very simple language, means it is easy to learn, it is easy to understand, and though the structure of this language is very easy, so you need not to waste your time during learning the syntaxes and semantics, and you can learn it as by day-to-day practice. It looks like a simple English-like language, so you can focus more on programming rather than learning the syntax of the language. It is an open source language, means it is easily available on the internet. You can download it and use it, and if you want to make any changes in the programming, in the basic structure of the software available on the internet, you can also do it. It is an interpreted language. As I told you earlier, when we are programming any language, we program in the human understandable language, and the computer does not understand it. So there is a language processor who converts the language into the computer understandable language. There are various types of language processors available. First, when we have only the machine language, there is no any type of language processor is required because it is already in the computer accessible form. But when we had developed the assembly language, we need a language processor named assembler. So the assembler converts the assembly level language into the computer understandable language and the output into the assembly language again. As the programming language evolves, we will have the low level languages and high level languages, and then we have two important types of language processors available, that is compiler and the interpreter. So the basic difference between the compiler and the interpreter is that when we are using the compiler reads the complete program as a whole and then converts it into the object code, and then the object code will get executed. And when we are using the interpreter read every line and then convert it and execute it. There is a basic difference between the both, that when we are using the compiler, the whole language get converted as once in a one go, and when we are using interpreter, the every language or every line of the program will get converted and executed. And in the case of the compiler, if there is any error in the program, the list of the error will be shown in the end of the compilation. And when we are using interpreter, so the error will show after the error has occurred. Means if there is any error in the third line, then after the third line the converter and the execution will stop and the error will be displayed. So this was the explanation about the compiler and the interpreter, and we all know that the Python is an interpreter language, as I told you earlier. It is an object oriented language, means there are few basic concepts like object, classes, inheritance. So the Python follows all the object oriented concepts. When we are reaching to the topic, we will discuss it one by one. It is extensible, means if we had written a code of program, we can add some more codes to it. It is a high level language, as I discussed you earlier, and it is a portable, means you can use it at any program in the Windows, on the Linux, on the Unix, on the Android also. So it is a portable language. And the libraries So it has a huge number of library which can be included according to your need, and when we have to program any special type of programming we want to do, we will use the library according to the need.